Hello guys, today I'll show you guys how to find the first and last position of an element in a sorted array. So given an array of integer nums sorted in ascending order, find the starting and ending position of a given target value. And they want us to have our algorithm run in big O of log n. And then if the target is not found inside the array, we return -1 and -1. So the problem is basically asking us for a really simple search across the array and returning us the starting and ending positions inside another array. So let's get started. So first I'm just going to copy the solution and then paste it here so we can work with. Indexing it to my keys. Okay. And so notice that they want us to run this in big log of n. So basically that means that we are not allowed to do a linear scan across the whole array because that would be big O of n. So the first thing that should occur to you is that we should use a binary search approach. Basically we pick a middle point and then we iterate to the left and the right side based on how far away we are from the value that we're looking for. However, there's a twist to this problem in the sense that binary search only finds us the location of the target value we want, but since there could be duplicates and they want us to find a range, we are not guaranteed to get the first and the last occurrence of the target value. So what we could do is we can do a binary search first time to find any arbitrary value inside that range. Because since it's sorted, we know that the target value, if it exists, will always be in the same continuous array in the middle. For example, for this example, we'll have 8s right in the middle here. And what we could do is that once we find any one of these numbers, for example, one of these 8s, we can do another scan to the left and the right of that number to find the boundary, basically, that ends. And to ensure that we're also still running in log n of time, we can do the left and right search with binary search as well, but it will just be a bit modification to it. Alright, so let's get started. So basically, first of all, we have to make a generic binary search algorithm. So we're going to set the left and right to basically the beginning of the array and the end of the array. And while left is less than equal to right, I'm gonna floor it. And then the generic binary search algorithm, if target we're looking for is to the right, then we want to shift our left search over. And then if it's the opposite, then we shift the right down. And then else we find it, we're gonna return an array of our results, and we're actually gonna make this easier and create some helper functions that I'm gonna fill in later, and that will contain results. Else we know that when this while loop ends, we will not have found anything. That means that the target value does not exist, so we just return -1, -1. And so let's define our two helper functions. Sorry. First one is going to call find left. This will find the left boundary, and what we need to pass in is the array itself, and then we're going to pass in the leftmost boundary, which is going to be basically the 0th index for now, and we're going to pass the rightmost boundary, which is going to be the target value, the location of the target value we just found, and that location is arbitrary, and then we're going to pass in the target value as well. And it's the same thing for the helper function for find right. We pass in the array. Instead, this time your left boundary will be the location of the arbitrary target value we found, and then the end location would be the end of the array. So then we also pass in the target value. And then just filling some functions. You can name this however you want, but I'm just naming it like this just because. And then so let's define our both functions. So they're very similar. We can probably create another helper function to you know, even like abstract this even further, but I'm not going to do that right now. So for find left boundary, we basically need to say, hey, we know that we have our right value, there's no value with the target value that's going to be greater than the right boundary. So all I have to do is shift, look mostly in the leftmost side, and then shift the left and right pointers accordingly. So basically do another generic binary search, except this time we're gonna say if our target value of the middle is kind of how do I say this? If our value in the middle is less than our target value, then we want to shift our left pointer up, right? And then here's another thing. So how do we know when to stop? We will know when we can stop our search when we're at our target value and when the value to our left is less than the value we're currently on. That means that we have found the leftmost target value location. So basically we just check if my left side is less than my target value. If it is, great, we found the leftmost target value location. Else, we're just gonna shift the right pointer down as well to narrow our search. And then worst case, nothing happens, we return the left because that means that we're already on the leftmost. That means our left side, basically the index 0 is our leftmost occurrence of the target value. And for find right, you guessed it, it's going to be the same thing. Very similar, but if our target value is actually to the right, which means that our value currently at the middle is greater than our target value, then we're going to say shift our right pointer down because we're trying to find our target value, which has to be less than the value we're currently on. And then else, if like similarly, like I said before in the find left, in find right, if the value on the right of the current value we're on is greater than the target value, that means we have found the rightmost target value location. So we can just return middle, and then else we're going to shift the left up. Basically it's the same concept as find left, except we just reverse everything we did, and that should be pretty much it. Let's try it out. Let's see first if it runs. Oh, forgot something. Find left got 5 provided, huh? Oh, sorry. It's in the class definition. Here we go, that's expected as well. Then let's try submitting our solution. And there we go. I hope this makes sense. And in the end, since we're doing basically 3 binary search operations, the final runtime is still going to be big O of log n. Thank you. I hope that was really helpful.